What is up, team? Topic 16 practice quiz. I'm going to go through every step of every problem. Feel free to pause, rewind, take what you need as I go through all these. Learning target 16.1, problem 1a. It says, what is the general form of the equation of a circle? That's the one where it's x minus h squared plus y minus k squared equals r squared. That's the general form of a circle, the equation of a circle. Part B says, what does the R represent? If you have been paying a little bit of attention, you'll remember R stands for the radius, the length of the radius of the circle in the equation there. Now, what do the H and K represent? The H and K are the X and Y coordinates of the center. The center of the circle. So you can tell by looking at these two numbers here, whatever this value of h is, whatever this value of k is, you can figure out exactly where the center of your circle is, and the radius will tell you exactly the size of your circle. So you can see an equation of a circle just like this and interpret it and be like, okay, I know exactly how big this is, and I know where it is on the coordinate plane. Pretty cool. You can kind of skip a few steps instead of graphing the whole thing. Okay, here we go. Number 2, it says, what is the equation of the line centered at negative 2316 with a radius of 7? So let's break it down using what we just talked about here. Radius of 7, that means our R value is 7. Cool. And our H value, that's the X coordinate, is going to be negative 23. The K value is going to be 16. So now all we need to do is take this R and plug it in. Take this negative 23, plug it in right here. Take this 16, plug it in right there. So it's going to be x minus, this part is a little bit funky because it's x minus negative 23. So eventually, well, actually, let's do it right now. We'll simplify that into a plus. So the next piece, y minus 16, that's the y minus k, but our k value is 16, equals r squared. In this case, it's 7 squared. You can also represent that as 49, your call. So this is it. Maybe I'd simplify it ever so slightly by removing one of my plus signs. X plus 23 squared plus the quantity of y minus 16, yikes, squared, don't forget that square, equals 7 squared. Here is the equation of the circle we are seeking in question number 2. Number 3, the equation of the circle is given as this. What is the radius of this circle? Interesting. So I'm noticing the r, normally we have r squared over here on the right-hand side. That term over there isn't squared. So it's really tempting to say that the radius here is 11, when in fact the radius here is the square root of 11. Reason being is because if you take the square root of 11 and you square it, well, what happens here is the square and the square root effectively cancel each other out, and you get 11. So if this term over here is not squared, like this one is not squared, you'd actually find the square root of that, and that is your radius. So we've done examples where this number all by itself is 100. Of course, the square root of 100 is 10. That's a little bit easier to kind of fathom what the radius is. This one being the square root of 11, that's a little annoying. I get that. But it is what it is. It's probably like 3.2-ish. I don't know exactly. You can throw it in your calculator to get a decimal approximation. But for quiz purposes, square root of 11 does the trick. Okay, coordinates of the center. That's where we just look at our h and we look at our k. This is always in the form of x minus h, so that means the h value is 9. And this is in the form of y minus k. Well, this is a positive number, so it's actually y minus negative 80. So the y coordinate of our center is at negative 80. So it goes over a little bit on the x-axis, and it drops way down to negative 80 on the y-axis. All right, I'm going to pause this, reset it up again for the next questions. Okay, here we go. Number 4 and 5 from Learning Target 16.1. Number 4, it's an interesting one. We need to dust off some old formulas, distance formula, midpoint formula. I have them listed over here. So this situation, we have a diameter with endpoints at points D and E. 2, -5 are the coordinates of one endpoint, and 4, 1 are the coordinates of the other. So remember, a diameter is a chord. It stretches all the way across the circle, and it must go through the center of the circle by definition. Therefore, if we wanted to find the radius of this particular circle, we have to find the length of the entire chord, or the entire diameter, and then chop it in half. because the radius is exactly half the length of the diameter. So we're going to use the distance formula to find the distance between these 2 points, and then whatever we get, we chop that number in half. Cool. Another formula we need to use is we need to find the center of the circle. So we're going to find we're going to find the midpoint between points D and E, because we know this thing goes to the center of the circle. By definition, it's a diameter. So we're going to find the midpoint of these 2 points, and that's our center. Once we have our radius and our center, we'll throw them in the equation that we've been working with. Let's do the distance formula first. It is probably the trickiest part. So here we go. First thing I like to do is I need to assign one of these x1, y1, and the other one x2, y2. So I'll call this x1, y1, x2, y2. I always label mine so I don't get lost. Okay, so the distance between these 2 points, square root of x2 minus x1. So for us, that's 4 minus 2. We square that, and we add that to the difference of 1 minus negative 5. And we square that. Some careful PEMDAS now. 4 minus 2 is 2. So we have 2 squared. 1 minus negative 5. 1 minus negative 5 is positive 6 because it turns into an addition problem. So now we have 6 squared. 4 plus 36 equals the square root of 40. Okay, cool. So our distance here is the square root of 40. Well, let's chop that in half to find the radius. This is the length of the diameter. We want the length of the radius. So our radius, our R value, equals the square root of 20, exactly half that of the square root of 40. We could probably simplify this ever so slightly, but I'm happy to leave it as is. Happy to leave that as is. All right, midpoint. This one, same thing. I'm going to leave my labels, x1, y1, x2, y2. We're going to use them the same way. Midpoint formula, of course, is a little bit easier. Just find the average of the x's, average of the y's. So it's going to be 2 plus 4 over 2, and then negative 5 plus 1 over 2. 2 plus 4, of course, is 6. Half of 6 is 3. Negative 5 plus 1 is negative 4. Half of that is negative 2. So the midpoint of this diameter is 3, negative 2, which is also the center of our circle. So this is our H, this is our K, this is our R. So if I'm setting this up in the general form, it's going to be X minus H, which is 3, squared, plus Y minus K, but in this case, K is negative, so it's going to be Y plus 2, quantity squared, equals the square root of 20 squared. Because this is our radius and we got to square it. If we wanted to simplify that, this is similar to the last one with the 11 just a moment ago. What we can do is we know the square and the square root are inverse operations. They cancel each other out. So effectively, we can just say that the right-hand side is just 20. Just 20, and the radius would be the square root of 20, as we showed here. Okay, that's number 4. Number 5. This one here, it's a little bit of a doozy. So the circle contains the points A, B, and C, and the coordinates here. So we're going to find the equation of the circle, and we're going to graph it. So the first thing I would do is I'd plot these 3 points, and this is how I'd suggest doing it on the actual quiz itself. Be prepared to use a straight edge, and I'll demonstrate all that here in a moment. But definitely, you're going to have, there's a chance you'll have a problem like this. I would do it exactly how I'm about to do it. Okay, so point A is at negative 2, 3. Negative 2, 1, 2, 3. Right here is where A lives. B is at negative 2, 7. Negative 2, 1, 2, 3, 4, 5, 6, 7. So that's B. Our C is at 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Great. Yep, these have the same y value, whereas these two have the same x value. Cool. All right, so it says find the equation of the circle and graph it below. We discussed this in class, and what we learned, or what we were reminded of, is Euclid's first proposition in book 2, which is all about circles. He showed that if you find the perpendicular bisector of multiple chords, 2 or more chords within a circle, that they intersect at the center of the circle. basically, so what we know here is that there's some circle. It kind of goes through here. It pops out here a little bit. It goes down. It comes around. I don't know exactly where it is. I don't know exactly where the center is. It's somewhere in here. But we do know that these 3 points are on the circle itself. So we're going to connect these 3 points, and it's going to create a right triangle, coincidentally. And we're going to find the perpendicular bisector of each of these 3 chords. Now, the perpendicular bisectors all intersect at the center. That's Euclid's proposition 1 in book 2. We just talked about that. So on your quiz, you're going to be doing this yourself with your ruler or your straight edge. It can be a piece of paper. It can be the side of your calculator. It super doesn't matter. I happen to have a yardstick. So I'm going to connect these points A, C. Again, they lie on the circle itself. So this is a chord of the circle that we're looking at. As is AB. This is one of the chords of our circle. And then AC, also one of the chords of our circle. Again, I want to recognize, I know that this looks like a right triangle right now, and we're like, what the heck? Why is this a circle? Hang with me, it's coming. Okay, the next move, perpendicular bisector of each of these chords. That means we need to find the midpoint of each of them, and we're going to eyeball it because it's on the graph. We can figure that out. And then perpendicular just means a line that meets at a right angle. So BA, the distance between BA is 1, 2, 3, 4 units. So right in the middle of that is 2 units. Half of 4 is 2. So right here, 1, 2. Here's the midpoint of that chord. We're going to put that on pause for a quick second. Let's find the midpoint between A and C. The distance here is 1, 2, 3, 4, 5, 6, 7, 8 units. Yeah, so the midpoint is 4. So we're going to count 1, 2, 3, 4 units. Here is the midpoint of that chord there. Great. The midpoint of BC, that one's a little bit trickier. I'm actually going to put that one on hold because we only need 2 chords. So let's just do the ones that are vertical and horizontal because they are easier to work with. Next, I'm going to draw in the perpendicular bisector here. So I'm trying to make this at a perfect right angle. And here it is. And then the other perpendicular bisector. So I'm going through the midpoint of AC, just drawing it all the way through. And then meet at this point right here. Coincidentally, it's also on chord BC. That's kind of cool. So the center of our circle is right here where they meet. So the center of our circle looks like it's at 2. 1, 2, 3, 4, 5. So let's capture that right now. HK is at 2, 5. We know how to plug that in the equation. That'll come in a minute. Next, we need to find the radius of this circle. This one is going to be a little bit trickier. So what we're going to do is we need to find the distance between 2, 5 and any one of these points. It super doesn't matter which one we pick, A or B or C. I'm going to pick C for the reason that both of the coordinates are positive. This is at 1, 2, 3, 4, 5, 6. 1, 2, 3. This is at 6, 3 is how we found that. So I'm going to find the distance between 2, 5 and 6, 3, which is this distance right here, and that will be the radius of my circle. So I'm using the distance formula yet again. I'm going to label this x1, y1, x2, y2. Distance equals square root of x2 minus x1. So that's 6 minus 2 squared plus 3 minus 5 squared. 6 minus 2 is 4. So we have a 4 squared in here. 3 minus 5 is negative 2. And we square that business as well. 4 squared is 16. 2 squared is 4. So here we are again with the square root of 20. Coincidence, but this time it's the radius over there. Oh no, the radius was there too. So this is definitely a coincidence that we got the same thing, but it'll work for us. All right, so to finish this off, the equation x minus h, which is 2 squared plus y minus k. K is 5. I'm looking up here for that. And on the right-hand side, it's r squared. So the square root of 20 squared. or as we discussed a minute ago, you can just call this 20, because the square root of a number that's being squared is just whatever that base number is. Okay, this is the end of Learning Target 16.1. I'm going to do 16.2 here in a moment. You're going to have either a question like 4 or 5 on the quiz, so be prepared for both of these. Learning Target 16.2, here we go, equations of parabolas. Number 1, I wrote it ahead of time. The question is, define a parabola using the terms focus and directrix. So the parabola is the set of all points equidistant, the same distance away, from both a given point, which we call the focus, and some given line that we call the directrix. So this is kind of the technical definition of a parabola. The simple definition is, the smiley face, the frowny face, the one that points to the left or to the right. That's what we're used to, but technically here's what's going on. A demonstration of that is over here. I've kind of staged number 5 for us. We have the x and y axes here, and then this dashed line is the directrix for this particular problem, and then this point over here is what we call the focus. That's just a regular point. The dashed line, that's just stylized so it stands out. It's some given line. So the parabola that we're going to make over here in a minute, every point on the parabola, if I was a perfect computer drawing this thing, would be the same distance away from the directrix, each point, as it is from the focus. So it's kind of a cool thing. That's how parabolas are defined, and that's how they're created. All right, let's move forward. Let's talk about some of the equation representation stuff. Number 2, general form of equation that opens up or down. It is in this form right here. Y equals x squared over 4a. That's a given thing. You don't have to figure that out. This is me handing it to you. There are 4 general forms. Check the notes to make sure you know if it opens up, down, left, or right. Up and down is this one. If it's up, the x squared is positive. If it's down, the x squared is negative. And we'll talk about left and right in a second. Okay, 2b, the distance between the focus and the vertex. So it asks, what is, oh, yikes, I wrote this down slightly incorrectly. These should not be a's. These should both be the letter P. Yikes. Okay. So that makes this question make more sense. What does the P represent in this equation? That is the distance between the focus and the vertex. So if we look over here, we have the focus, we have the directrix. Well, the vertex is going to lie immediately in between them, because this point is going to be on the parabola. So it must be the same distance away from the focus as it is from the directrix. So the vertex is going to be here at the origin. So the p-value is the distance between the directrix and the origin in this case, or from the focus and the origin. They are the same exact thing. Kind of a cheat code with these is if you can find the distance between the focus and the directrix, chop it in half, that's your p-value, because that's the distance to the vertex from either side. All right, number 3. What is a general form of an equation that opens to the left or to the right? It looks like this. We really, all that happens is the x and the y's swap places. This one is y equals x squared over 4p. Here we have x equals y squared over 4p. X and y flip places. This one opens up or down, depending on if the top is positive or negative. This one opens left or right, depending if the top is positive or negative. If it's negative, it opens up to the left. If it's positive, opens up to the right. Okay, let's get into this. The directrix of this thing is y equals -3. The focus of this thing is at 0, 3. It says to graph both of those pieces. That's part A. So we're going to do that. Focus of 0, 3. So start here. 1, 2, 3. Boom. Focus. There it is. Directrix. Y equals -3. 1, 2, 3. This is going to be a vertical line because it's a y equals situation. So it's going to be here. I tend to do my directrix. I always do them dashed. That doesn't make them, it's not like a necessity. It just makes it stand out to me because it's not the line that we're focusing on, but it definitely influences the graph that we're about to put on here. Okay, so that's part A. We got both those pieces. This is find the p-value of this parabola. Okay, well, the distance between the directrix and the focus, we're going to find that distance and chop it in half. So we just can count up on the y-axis here. It's kind of nice. So 1, 2, 3, 4, 5, 6. So the distance between these two things is 6, but half of that, because we want the distance between the directrix and our vertex right there. So the p-value is 6 over 2, or just 3. Cool. Now what we're going to do for part C is what's the equation of the parabola? Well, we know it opens up or down, so we're going to use this general form. and we have our p-value now that we just found. It's 3. So it's just going to be y equals x squared over 4p, but our p-value is 3. X squared is positive because this thing opens upwards. So this equation, at the end of the day, for part C, x squared over 12. Done. We did it. And it'll look something, I don't know, something kind of like that. That's not perfect, of course. But the kicker is, each point on this parabola, anywhere you go, if I look right here, the distance between this point and the focus is the same as the distance between this point and the directrix. So if this is, a distance of A, this must also be a distance of A. That's true for everywhere on the parabola. It's also true for right here. This distance is the same as this distance. We'll call that distance B. I don't know what it is exactly, but I know that they match. The same is true at the vertex. The same is true here. The same is true, a bazillion points in that direction. That point is going to be the same distance to the focus as it is to the directrix. Now, at only one point on the parabola is that distance the p-value, and that's at the vertex. And that's the one that we're most interested in generally, because that helps us form our equation here. All right, last one, number 5. Thanks for sticking with me so far. Parabolas graph below using, with this focus and directrix, what is the equation of the parabola? I'm noticing I forgot to put in the actual parabola. I did it on the practice quiz, but not on the board here. It's something along these lines here. So what we need to take into account when creating these equations is 2 things. 1, which way does this thing open up, because that'll tell us which general form of equation to use. And then 2, what is the p-value? So this thing opens up to the right, meaning we're going to use this equation right here, just exactly as is. Y squared is going to be positive. So the form that we're using, let's tuck it right here. X equals y squared over 4p. Now our only move left is to find that p-value. The p-value is the distance, again, from the directrix to the vertex, which is also the distance from the focus to the vertex, or you can look at it as half the distance between the directrix and the vertex here. So on this one, easy peasy, you just count 1, 2, 3, 4, 5 units. To verify, you can count the other way, 1, 2, 3, 4, 5 units as well, or you can find the difference between these two, and it's 10. Chop that in half, you get 5. So our p-value is 5. Now we just plug it in. X equals y squared over 4 times 5, which is 20. That's the equation of this particular parabola. Expect to have questions on the quiz similar to 4 and 5. This is the kind of thing you'll be seeing. This is really helpful. You'll need to know this stuff for sure, because it helps inform how to solve and how to approach 4 and 5. But expect the quiz to have questions like 4 and 5. All right, long video. Thanks for sticking with me. Ask me all the questions. You got this.